Hey guys, we're on. I'm still getting used to all this like Twitch streaming stuff. Hi, I'm Laurel. This is the garden. This is like your first time you guys seeing our actual offices back here. So a lot has happened in the last couple of months. It's been since September since we've managed to stream, maybe even August. In those months we've run a ton of training for our active duty military members, which is always a lot of fun. We've gotten some of our first tenants in here at our co-building space, the garden. We've gotten ourselves moved in, which is always sometimes the hardest part of the transition. And we've got just a lot of exciting projects going on. And so today I'm actually going to walk you guys through our kind of most forefront exciting project that we've got going on, which we're actually doing in collaboration with the Smithsonian Arts and Industries Institute. So here's the exciting stuff. On December 7th, the Smithsonian Art and Industries building is going to be hosting an event called The Long Conversation. So this actually is going to go from 2 to 10 p.m. And essentially they've got this amazing list of speakers all lined up. People like, oh goodness, I didn't write any of them down. I know Cheech from Cheech and Chong is going to be there. That one I'm pretty excited about. I think that's going to be hilarious. One of the directors for all of the Jupiter missions and NASA is going to be there. Doctors who specialize in world-renowned cancer research, like pretty much this, as much of a smattering of different people as you can get, will all be there to talk about why they're hopeful for the future. And so it's called The Long Conversation because the format is essentially that two people sit down, they start talking, and after about 15 minutes, the first person gets up and leaves, and then the second person, or a third person sits down, and those two people continue the conversation. And after 15 more minutes, that second person gets up and another person comes on. So it's actually kind of this long flowing conversation that everybody has with each other, and they are giving away free tickets to this. So if you actually look up Smithsonian Long Conversation online, you'll be able to find a link to where the tickets are available. They're free. I think last time I checked, they all might be gone, but there is a wait list. And there are tickets available day of the event. So now here's why we get to be part of this exciting stuff. You might see people wearing one of these on stage. And so essentially what we at Building Momentum get to do is that we get to help them do their backstage event. And so what we're going to be doing is we're going to be teaching them to program and build these electronic name tags. So this is actually based off of a design that our CEO Brad and former Twitch star would wear around things like Maker Faire or other conventions, and he pretty much was really tired of introducing himself all the time, so he started wearing these. And so it's super helpful, and you don't have to kind of keep introducing yourself. You can just kind of go with the flow. The name tag does it for you. And you can kind of personalize it with whatever you want. Mine's very boring right now. It just says my name, Laurel Cummings, in case I forgot to say that at the beginning of the stream, because I'm forgetful. But it's a really fun little thing, and everybody can kind of get a chance to do it. So we're actually going to be backstage at the Long Conversation the entire time, all 8+ hours, showing people how to program and make these. They all actually run off this little Arduino Nano. So this is kind of the backside of it. You guys are seeing the end product. You can get all these parts from like Adafruit or any other retailer, probably less than $30. We laser cut the name tags, had them personalized, with the Long Conversation on there. And actually the LEDs shine through, and so just gonna sit on a name tag right here, and there you go. And so I'm going to walk you guys through how to solder all of this together, because we bought the kits and I haven't touched them yet. I'm going to show you we got a lot of it from Adafruit, one of my favorite websites, shout out. Send us free t-shirts. And so we're going to go through how you're going to solder together this LED backpack. You guys will notice this is actually something called a LED matrix. So these are what the LEDs themselves look like. You'll notice that they've kind of got a variety of pins on them. Let's see if that'll autofocus. Because if you look at it, you have not just one pin per LED to turn on, you actually kind of have a matrix, and so it kind of shows you right there. So what it does is it actually has one pin for every row and one pin for every column. And it does something called convolution in your programming, where it goes, okay, I'm gonna look at the row number 2, column number 3. And it's gonna calculate from which pins go high where it's supposed to be at. And so it's almost like it sends the signal this way, and where they intersect is what LED turns on. But thankfully we don't have to do the hardcore programming of all that because there's libraries. And so we're going to be using this itty bitty little Arduino Nano, my favorite little tool lately, to program these and control them. Because we want this, since it's a wearables project, you want it to be as low profile and as, sleek as possible. You don't want it to weigh a bunch. You don't want it to drag on your clothes. You want it to be discreet. So with these, we're actually going to be using 2 of these guys. So I have a second one right here. So, bada bing, bada boom. And we have this thing called a backpack. So this is actually, as you can see from Adafruit, I swear they're not a sponsor. It's a 16 by 8 matrix LED backpack. And all that says is that you solder, instead of having to solder all 16 of these pins, and then really 32 if you count both of them, to an Arduino Nano, which only has, trivia time, 13 pins. So 13 digital pins before we get into semantics. You can actually control all of these LEDs using 2 pins off the Arduino Nano with the backpack. So, if you take a look here at the very end, let's see if it'll focus for me. I'm trying to show you guys. Ooh, there you go. You see how it says SCL, SDA, and then VCC and ground. So VCC and ground, for anyone who's done any basic electronics, we know that that is our power supply and our ground connections. VCC is going to be 5 volts, which is super convenient because that's exactly what our Nano runs off of. Ground is ground. That's the easiest one. And then we also have SCL and SDA. Those are essentially serial communication lines. What serial communication means is that there are 2 wires. One sending information away from the Nano and one receiving information to the Nano. And it has these 2 wires, each one with a set communication direction. And that's how it's talking between the 2, between the Nano and the backpack. And then the backpack has this chip on it. You can kind of see it there. That's the logic board for this. And I haven't read the full data sheet. I'm a bad engineer, sue me. But what that is that actually is probably a multiplexer. But some people call it a mux. What a multiplexer does is it actually kind of combines signals. So remember how I was saying about how each row and each column, the 2 signals kind of combine to find one LED? Well, that multiplexer does the math for us. So like I said, we don't have to program it into our Arduino, and we don't have to use up processing power on our Arduino Nano, because again, we want this to be as small and low-key as possible. So, I'm going to show you guys through all of soldering that together. It's only about 4 wires. It's super easy. Don't get freaked out. We can all do this together. I also have these bad boys. So, this one's a bit dusty still. I laser cut these yesterday. These are the name tags that we're doing. So, we have acrylic laser cut name tags. So I kind of like this. I really like the translucent effect, and purple is a big popular color on their site. And so we decided to just make custom name tags. And with a laser cutter, these took like about 20 seconds tops. It's awesome. It's one of my favorite tools we have in the shop. So I'm just gonna get started working on this. I'm gonna, you can see that it's got this paper kind of on top of it. It's actually purple, but it's got this protective paper on it to help make sure that this doesn't get scratched too soon before I get it out in the open, and just make it look good. So, got my soldering iron here, but first I want to clean this up. So I'm gonna change my camera angle. Very fancy transition there. And I'm just gonna start weeding this. I'll have to get a much better microphone set up so that way we can have like the workshop ASMR experience. I don't know if that's something people are into. Ooh, but I know people are like this, so. It's just as satisfying as it looks. Ooh, check that out. Oh, it's gonna rip. Wait, let me try this one more time. Okay, that's some of it. So there's still some like little things in there. So what I'm gonna do is I'm gonna use my friend. I don't know, is this a weeder? I think it's just a pointy stick, but it's just nice and pointy, and I'm just gonna use that to clean this up. And so you guys notice that like the edges of this are completely clean, but then this like kind of engraved section is all dusty and stuff. That's because with laser cutters you kind of have 3 different types of cuts that you can make. Or not cuts, but functions, I should say. With a laser cutter you have a vector, which is just a clean straight line that you can use. And it's quite lovely, and they're just perfectly crisp. And so you can draw that in programs like Inkscape, which is free and open source. You could also do it in programs like Fusion 360. That's what I tend to do stuff in because I use it for my CAD and 3D printing stuff. And so it's really easy for me to just draw the lines instead of making it 3D, stop at the 2D stage. And you're all set, Bob's your uncle. And essentially, you can get to the vector cut stage very easily. I did these on a ULS laser that we have in our shop. We have 5 of them. So if you need laser cut work done, you should come by and check out our place in Alexandria. But this white section that I'm weeding out, that is a raster. So with a vector, like I said, it's one clean continuous line. It's super clean. It's completely straightforward. It is essentially a solid object in terms of image. But with rasters, it takes the image, and you know how images are made out of pixels? Well, essentially, it burns each of those pixels in a line. And it does this like down, down, down. And so like that's why this is actually super dusty. Yeah, I forgot. Wow, I'm really bad at these. Is there a market out there for bad ASMR people? Maybe I'll just have to make it. Oh, there's an echo? Thank you for letting me know. Sorry, let me take a look at that. Okay, cool. I think that should be better. Thank you. Chat. Hopefully that wasn't going for too long. Yeah, still a little bit more weeding. I let my inner perfectionist out when I work on this sort of stuff. It's very soothing, especially if you just sit down in front of the TV. Alright, so there's that one. Perfect. Okay, so since we've got that part set up, next I'm going to, I guess, start some soldering. So I've got my soldering iron over here. I have to take this down, try to prop it up that away. Cool. So I know we've done a couple of videos about soldering, but I'm just still gonna talk through it because that's what I do. I'm a professional talker. What I'm pulling out right now is called a JST connector. And what these are really good for is that, because these are wearables, they work really well with LiPo batteries. And so we bought these really itty bitty guys. This is my whole battery pack. So this is just a 3.7 volt LiPo. Works great. And the thing is that it has a male JST connector on it, which is like kind of an industry standard. You kind of see it right there. This camera really does not like focusing. So what I'm going to do is I'm going to just solder this bad boy in on our 2 VN and ground pins on this Nano. Oops. So they're right over here, the last 2 ones. And so I want to make sure that I don't do it upside down, because then I would be putting the polarity in backwards, and that would be no bueno. Okay, so I'm just placing it in like that. I'm just gonna set it down. I got these helping hands, and I'm really bad about using them because I am just a slapdash kind of person. I accept that about myself. But there are definitely projects where you don't want to be slapdash. This is like my favorite new thing. I don't know how I never knew about this. I mean, I went to school for electrical engineering and I didn't know about tip tinner. So, if you've ever soldered before, you know that part of the process is preparing your tip. You have to tin it right. Originally, I always thought the way you do it is you let it get nice and warm and then you just touch some of your solder to it. Like so. Apparently not. Apparently, there's this stuff called tip tinner. And all you have to do is touch it in there. It just melts right on. I clean it off. Gotta get some aggression in it. And it's perfect. Perfectly tinned. I love it. Works every time. 60% of the time, it works every time. Okay, so let me try and get fancy with this. Oops. I'm just trying to prop my JST connector in such a way that it will not fall out before I can solder it. I'm trying to, at least. There we go. That should do it. Now, you can't forget this step. So, with soldering, we tin our tip first. We prep our helping hands. That's what these are called. And then we get out this stuff. Flux pen. For that, is there a makers and crafting category? I thought there was just creative. But with this flux pen, this actually can help our solder flow better onto our board. It just pretty much helps the solder get nice and liquidy and go where you want it to go, which is the contact pads, which are pretty much like these little copper spots. That's spots where the solder will stick. But the blue is called a mask and it won't stick there. So all I'm doing is on the 2 pins I'm soldering to, ground and V in, I'm just putting a bunch of this flux stuff on it. Oh, creative is gone. Okay, good to know. Thank you so much, chat. Yeah, I'm gonna update my category to makers and crafting. As you can tell, I'm still getting a hang of Twitch. It's an entirely new category for me. Well, that should be updated, so works for me. Thank you, Dark. Oops. Okay, so now I'm ready to solder, right? And so what I'm doing, I'm right-handed. I'm switched on camera, but I'm right-handed. So I like to hold the soldering iron in my right hand, and I will pull out some of the solder. This is solder. It comes in a nice, friendly pencil-shaped tube, I guess. And I pull out some of it. I like a nice little piece. And what you do is you bring in your soldering iron to the pin you're going to solder to, and you use that to heat up the metal, and then you bring in the solder itself. And essentially, like, this is like kind of the rookie's mistake, is that people will glob solder onto the top or onto the tip of the soldering iron and then kind of paint it onto the pins. But it actually goes the other way. So let me get these guys, and then once I do this, I'm gonna test my battery to make sure my Arduino turns on. Now there's definitely no soldering ASMRs, right? That like cannot be a thing. Cool, cool, cool. So I'm just taking a look at my solders. They're decent, a little bulbous, I'll be honest. You want it, if you're making a really good solder, you want it to look like a mushroom. But the lovely thing about soldering is that it's actually forgiving. Quite contrary to belief. And so, you can just like hold your soldering iron on the joint and it'll just remelt. So I'm gonna plug this in. We'll see if, so when you turn power onto an Arduino, like if I just use my laptop right now to power it on, this nice bright red LED comes on. Perfect. So I just wanna make sure that when I use my battery, that LED also comes on. Aha! Perfect. You have to do the smell check every once in a while to make sure things aren't burning. You'd be surprised how helpful that can be. Now the trick is going to be getting it out, because it's a bit of a tight fit. There it is. Coolio. So, that works. Love it. Next up, we're probably just going to want to go ahead and solder these backpacks into this, the LEDs into the backpack. Now, it looks like, what I'm checking for right now is to make sure that these are omnidirectional, that I can put them in any which way I want. And I think I can, because it does not really look like there's an up or down. I'm just gonna make sure I put them in both with this like text on the top. You guys are probably thinking like, why does she sound so uncertain? This is actually the first time I've built one of these. Like I said, this is one that our CEO Brad made. So we are all learning together, my dudes. Okay, so all you have to do is just, you put these through the nice pinholes. And it's got like nice little prints on there so you can see how they're supposed to line up. Perfect. Coolio. So now I'm going to get these all in my helping hands. And we're just going to do a bunch of soldering. Oof. You know what? I'm going to be tricky. I'm going to go get a piece of tape. One sec. I know that's super exciting. I need wire too. Oh, I got the wire. I'm talking to I'm talking to the internet, Julia. Thank you. Off screen, coworker Julia. So, this is just tape, and because I'm lazy, I'm actually just gonna like tape these in. Because I just like, I know I don't want them to fall out. And I mean, I have to solder them still, I get that. But I can still make my life a little easier. This is actually double-sided tape, which is totally fine and one of my favorite things. Oh, that doesn't stick. So. Yeah, taping stuff down instead of just doing whatever. It's super helpful. Instead of like futzing with helping hands. Because like, yeah, helping hands are really great if you're trying to do like very small components, but when you just have to do like a field of these, sometimes it's just easier to tape things in. Like for example, you see with this Nano, there's no headers on it. And that's because, I mean like that's just how some of them ship. And I had to solder about 200 and some of them together. I had some help from some lovely Marines, which was very nice of them. But I'm not gonna like futz around and get them to fit in my helping hands for, 2 hours or something. I just taped them all in. And it works, If it works, it's not dumb. That's like the rule. So, I got my things in. Gotta get my flux pen, shake it up. And I'm just like applying it liberally. You get some flux, and you get some flux. And we're just gonna go to town. There's a lot of pins to solder. So, since we're doing this live, I can't like cool magic time lapse this for you. So you guys are gonna get to see this in media res. Or not in media res, in life res. But while I do this, I can tell you guys about all the cool stuff we've been doing. So, like I was saying, a lot of stuff has happened in the last couple months. Some of our teammates actually went down to North Carolina after Hurricane Florence hit, and we went to one of the towns down there, Jacksonville, and helped out with some of the post-Florence hurricane relief. And I was actually on that team, and that was really nice because I have family that live down there. So it's good to be able to that we get the chance to help out with people, and some of what we were doing was just doing stuff like this. We were actually building very small fuel gauges that essentially use a little potentiometer, which is a turnable variable resistor. It's just like a little knob that has a resistor inside, and when you turn the knob, it changes the value of the resistor. We were essentially using those. Does that look good to you guys? Decent enough, right? To create these fuel gauges that could wirelessly transmit what their value was, so that the Marines didn't have to send out their guys to these like remote, fuel generators out in the middle of nowhere to check their fuel levels. And so that was a really cool project. We 3D printed the case for it, did a lot of soldering to build the electronics, which had like a little NeoPixel ring, which we talked about on our last stream, and also had an XB radio on it. And so the XBs are kind of our new fun toy around the office. They're essentially little 2.4 gigahertz radios that are super user-friendly for the radios that are available on the market. Yeah, look at that. As one of my professors used to say, now we're cooking with gas. So yeah, we made these transmitters that could essentially send their fuel level wirelessly. So during a hurricane, these guys don't have to leave, safety to go check out what's going on, to see what the fuel levels are at. And these are like industrial sized generators. They're like the size of my truck. It's insane. So that was a really cool project they were able to help out with. And so it also helps out because, kind of helps us prepare for what we might be facing ourselves next time we choose to do some disaster response. A couple people on our staff, like our CEO and our president, Brad and Albert, including also one of our other coworkers, Julia, have done a lot of disaster relief work from a maker's perspective, which is really cool, and it's really helpful. I know that's actually where Brad and Albert got Julia, who's down in the Virgin Islands, after a hurricane hit. And so, with all the crazy storms that we've been having over the last couple of years, being able to provide that sort of support can be really helpful. I've grown up on the coast for most of my life, and so I'm pretty familiar with what happens when a hurricane comes to town. And so hopefully, maybe there's some ways that we can all work together and build some really cool projects for that. Maybe that's something you guys think of something. I guess comment. Speaking of that, though, if there are projects that you guys want to see us to do, we totally want to hear them. We do a lot of work with drones. Henry, our lead drone guy, he has been in some of on our YouTube page some lately. You guys should go check it out. We've been talking about cool drones to build for just fun videos or like how-tos. One of the big ones is I think it would be really fun to make drones out of things that shouldn't be drones. I got most of my inspiration from dumb photos on the internet. Like I saw someone made a drone out of a croc, like the shoe. And I thought that was the funniest thing. So that kind of got us talking about like different things that could, like drones that shouldn't be drones. Someone suggested Tupperware, which is always funny. Because then you can just like have your like leftovers fly themselves out of the fridge to yourself, and that would be nice. I think that's like peak America right there. Okay. I think I've got all these bad boys. If this will focus. So I'm just gonna take all this tape off. And so, like I was saying earlier, we only have to make 4 connections between the Arduino and this backpack. So, what I'm actually going to do, though, is I'm actually just going to go ahead and try to tape this in place. Because I know I want it to sit here, right? Because we want it to be as compact as possible. And so if I futz around with it, I think getting it to sit just around here. That's nice. That's pretty low profile except for this connector. Yeah, I think that's gonna be this, but I'm gonna use some of this stuff. This is my favorite stuff. This is called M5. I call it M5 tape. We've had like office discussions though about what it's actually called. This is tape to stick something you don't want to move. And it's awesome. So I'm just going to cut it down to size. About Arduino size. It's double-sided and it's kind of foamy. So it gives you some nice clearance. And it lets you kind of like, especially with electronics, just press it down. You know what though? I'm thinking about it. I've had a thought. I probably want to solder my wires to this first. That would help. Because otherwise, I'm just going to be really annoyed about 20 minutes from now when I actually go to solder the stuff and it don't work. So yeah, this long conversation though I think is going to be super exciting. New wire. It's so good. So I'm going to go ahead and follow normal wiring conventions. This is a brand new pack, so I'm going to have to like set it all up, which is a-okay with me. So, wiring conventions, right? When you do VCC, you typically want that to be red. That's why I'm messing with this one first. That's how you know it's kind of your hot power supply. And this is all for just DC power. When it's AC, you actually kind of have different conventions. And it also actually depends on your country as well. All I can speak to is the American system. I think European is vaguely similar. But I'm going to be honest, y'all. I'm not sure. And then you want to use black for ground. And I, personally, like to use 2 different colors for my serial out and my serial in as well. So today, I'm feeling like we're going to use this beautiful baby blue. I think I'm also going to go for yellow. It just helps for debugging because then you can, if you have, 12 of these in a system, you can kind of more easily follow the wire as opposed to just setting it up in one color and you're trying to drag and trace around. You can do it visually. A good wiring convention never hurt nobody. Perfect. So, I'm going to go ahead and do my power supplies first. I forgot wire snips. I've actually started hiding these in my desk because we are all constantly looking for them. And I am so bad at keeping track. So, I'm liberal with this. I'm going to cut a good amount of length. And so we still know where we want this to go, right? So what I'm going to do is I'm going to solder, I think what I'll do is I'm going to solder down Arduino end. And then I can solder it over here after I have attached this. So I only need to strip one end right now. Normally you have wire strippers for this, but I like using these. They're versatile. So all I did was rip off the plastic coating at the end. And what I like to do, since I'm feeding this stranded wire in a through hole, I like to just twist it a little bit, and if you're having trouble making sure this fits, I bought really thin gauge because I have this problem all the time and I've learned. But if you don't have thin gauge, if you have thicker gauge, you can actually cut off some of the strands and it won't hurt anything. You can tin it just like you would with the tip. You can prep it by adding just a little bit of solder to the top of the wire. But I know that this is gonna fit. So I think I'm gonna go over here. So Arduino Nanos have 2 points that they have a ground on. I'm using one of them for my battery connection. So it means I kind of have to use the other one for my other ground. And I'm gonna make sure, what I do is I pull it through and then I actually kind of bend the wire some so it doesn't slip out. And I'm just going to actually use my helping hands because this is what I think they're best at. These little wires never want to stay put. And sometimes I like to even hold them at an angle so that they kind of are inclined to go the right direction. But I'm gonna clean it up anyways. Alright, so you see there, I just kind of fed it through and then, come on. Fed it through and then slapped some solder on it. Because this is a wearable, I want to make sure that it is not too fragile, that it breaks anytime I like jump up and down. Like say what if I have to do jumping jacks to get myself hyped up for my talk? That'd be bad. So that means making it tough and giving it nice strong solders. But the lesson I've learned over the years is that you actually don't want to let the solder get too far down the wire, or else the wire becomes too rigid and it's more likely to break off. So right now it's kind of got that flexibility still, which is really good. What I'm doing right now is I'm just kind of cleaning up the whiskers. I don't want anything else to get to that. I'm also, I think, gonna melt it a little more, just to make life easy. Cool. And now I'm going to do my VCC line. I'm just cutting about the same length. Like I said, wire is cheap enough, so measure twice, cut once, or just wait to cut until later. Alright, stripping it and twisting it. And so this is actually going to go in a pin on the other side labeled 5 volts. And so I'm just feeding it through because I know I want it to go in the same direction, so I just fed it so that it kind of lays parallel to the board, and I twisted the wire on the underside to lay down. I'm going to retin my tip right now because it's been a little while and it's never a bad thing. Solder that spot. Remember, you're using the soldering iron to heat up the metal, and then you bring in the solder. So the solder is melting to the metal and not the iron, which is awesome. Alright, I'm going to clean up some more. Beautimus. You have to find delight in little things, guys, okay? Don't judge me. Alright. Cool. I just want to make sure that these don't break because I would feel super bad about that. Alright. So, now here's the thing. We have 2 other connections, right? We have our power, and we have our VCC, and we've done our ground, at least from the Arduino side. The other 2 connections we need to make are to the SCL and the SDA pins. We're actually just going to solder those into analog pin 4 and analog pin 5. So those are going to be about the same length, so I'm going to cut them at the same time. Boom. And so essentially what we're going to do is we're going to tell the Arduino when we're doing this part from a coding standpoint. We are telling pins analog 4 and pin analog 5 that they're going to act like our RxTX pins. I'm just stripping a little bit extra because I went a little too short on the other one. I don't know if you guys can hear that in the background, but that's Charlie, our new shop dog. He's very cute, but his owner's away right now. We're collectively dog sitting. I'll see next time if he can make a guest appearance on the show. Is this a show? I don't even know. So, stripped it, I twist it, and now I'm just gonna feed this one through A5. Pull it through, and then I bend it. Bend it like Beckham. Is that actually a song, or is that just a phrase? I have absolutely no idea. Alright. Oh! Where did my flex go? Flex pen! I always forget this stuff. Because I'm too busy barreling into the next thing. Alrighty. Go ahead. Do that number. Solder it in. Perfect. Gonna trim this up. Cool. So that's one done. Aww. Charlie's upset. He very much still is a puppy. He's only like a couple months old. But he's already like almost up to my hip. He's just such a big dog. He's so much fun to have around though. I have a cat, but like it's nice having a shop dog. Shop dogs are just so important. People underestimate it. But whenever he gets into trouble, his full name is Charles. Oh gosh. He has a middle name too. Henry, I'll have to tell you next time. That'll just get you guys to come back. The promise of dogs. Alright. That should do it. Alright, and now I'm just going to trim this up. And then after all this, I think we'll be ready to tape it down. Get it nice and secure. I just want to make sure that there's no whiskers between the two spots because that can be wholly disruptive to electrical systems. Yeah, it's no fun when you have shorts, right? Okay, so that's our 4 connections. Check it out. Looks like a fishing lure. And now I'm just going to pop this tape on it. And like I was saying, it's kind of foam, so it conforms very nicely to the ridiculously bumpy surface with like pins and surface mount components. Oh, Charles! He's really upset, guys. Charlie! I know. I'm sorry, guys. Oh, looks like we need another piece of tape. So you can either use like this tape or you can use a hot glue gun, kind of whichever one's easier for you. But I'm too lazy to plug in a hot glue gun right now. So there we go. That's what I'm talking about. Look at that. Well, not that way, but sleek. Yeah, nice and lined up. Perfect. So, what I'm gonna do now is I'm going to take these to my power wires. I just like to get those done first. And I'm gonna route them over and cut them to the right length and just solder them in to those connectors right at the end. Would more of you guys start watching if I got the dog? Is that what we're missing? So I'm just doing the same thing as before. I'm kind of just cutting them to length, twisting the wire, and feeding it through. So that one's my ground. I'm also just kind of like placing them because I want to make sure that these aren't, you know, willy-nilly about, because you want to make sure that they don't get pulled out. People might be wearing, you know, some crazy clothes. I could get my flux because I'm so bad at remembering flux. There we go. Put that on. That on. And then, whoops, kind of missed. This is kangaroo soldering. That's what's happening. All I'm doing right now is I'm just kind of actually like remelting the solder to cover the hole. Because you want to make sure you have a solid connection. So let me see if I can show you that. There it is. Ugh. This camera hates focusing. How about there? Is that your sweet spot? We're working on it. But just gonna be doing the same thing as before. Trimming it up, making it look nice. Now I'm gonna route VCC. I think I'm gonna feed this one right underneath it. And then trying to just trim it. Ooh. Ugh, there we go. There we go. That works. Okay. In case you guys haven't noticed, I'm kind of a perfectionist when it comes to my wiring. And I like to make it, especially for stuff like this, as sleek as possible. So one of the things we're doing for the event is that we're not actually going to be soldering these there. We're going to actually tomorrow, me and a couple of other people in the office are just going to all sit around and have a nice little soldering party. It's totally normal. People do it all the time. It's not a dorky birthday party theme. But we're just gonna sit and solder and I guess gossip? Maybe, is that what happens? So now we got our VCCs working. This is a good time to make sure I haven't like blown something. So I'm gonna just plug this in. Cool, the Arduino turns on, love it. And I don't think there's a power indicator on the backpack. I'm gonna plug in this other one that I know works and double check that. Yeah, there's nothing. So, YOLO. Alright, now I'm gonna do these other two. they're gonna go to, I'm following kind of the wiring on this one that was made because I know it works. So A4 is gonna go to SDA. A4 is my yellow wire. It's gonna go right there. So I'm just marking where it's stripped. And then, boom. And then same business as before. You twist it, you pull it through, and you bend it. I'm just gonna go ahead and do the other one. And then, oh, I might have cut that one a little short. Alright, trim that, or strip that, trim it, and then feed it through, hopefully. Come on. There we go. Love it. It's the little things, guys. Sometimes success is just making your wire the right length. If you set small goals for yourself, you'll never be disappointed. Okay, and now I'm just going to solder both of these. And then second one. Oof. That one didn't go too great. Jumped over to the other connection. And so, all you have to do though, if it like kind of, if you accidentally get a short, I fixed it before I showed you, but I had a short between that really long one and the one next to it. All you have to do is just hold your pen on it, or your soldering iron on it. It'll fix itself. Have you guys ever seen like how water, you know, capillary action, when water can climb up a piece of string or something? It's that exact same thing. Solder acts just like water, which is really weird because it's molten metal. Cool. So, this looks like it's all assembled. I think I've done it the right way. So what we're going to do now is I'm going to plug it in, and hopefully we can start programming it. So my light's still on, that's great. I'm going to turn on my soldering iron and pull my keyboard towards me. So show you what's going on. Check it out. So one of them's working, other one not so much. And oh, you know why? I think I installed this one upside down. Okay, so we're gonna take a break and I'm gonna unplug this. And you know what? Guess what? We're gonna learn how to desolder. Let me make sure I get the right one though, because I don't want to uninstall the one that's the right way up. So let's see. Come on. Okay, so it's this one for sure. So I'm going to mark it very gently with my pen. There it is. Okay, unplug it. I'm going to untape this Arduino just to make my life a little easier. Alright. And then, so the way we're going to unsolder is that we're actually going to have to use this thing called a solder sucker. So what it is like a plunger. And you plunge that, and then when you get it, the solder nice and hot, you hit the button, and it sucks. So if I do, well, I can get it to stick to my finger. Well, almost. But what it is, it just sucks the molten solder up. So the first thing we want to do is apply just a bunch of flux. Just like an ungodly amount, because we want the solder to flow really well, right? So we're just going to throw a bunch of this on there. Okay. And now, you don't have to make sure that your tip is as tinned for removing solder, but it still can help. So all I'm going to do is I'm going to put this on my pin and then kind of hide my soldering iron underneath it. And then after some guesstimation, I'm going to go boop and check to see if it was unsoldered. Spoiler alert, it's not. So, oh. I didn't have my soldering iron on. That would do it. I'm gonna take a look and make sure that it's not that any of these are a bad connection. It doesn't look like it, so I'm just gonna go ahead and undo this and try to resolder. Make my life a little easier. And the nice thing about these like solder suckers is that you have to prime them, but the tips don't melt, which is very nice. And so you can kind of just like throw this on there, throw that, make a nice little sandwich, and then suck it up. And so all I have to do is melt each pin and suck. Yeah, and so you can see right there. Those like first two right in the middle. Again, this thing does not like to focus, but it's got those two look a lot cleaner. There it is. Oh, so close. Okay. So I just got to do that to all of them, and then I can pull out my LED matrix, flip it, and so you guys kind of see how quickly this can go. Ooh, one got a little stuck. All of them but this one at the end are nice and cleaned up. Sorry, I'm trying to see if this thing's melting or not. It doesn't look like it, but it keeps feeling like it. So, I think that's working. It looks... Yeah, that one's clean. I'm gonna try from the other end. And if that doesn't work, I have other ways of making this be persuaded. Do you guys have any big, exciting project plans for Christmas? I know we actually just put up all of our decorations here in the office yesterday, which is a lot of fun. And reminds me, I need to make a LED Christmas tree topper. Kind of forgot about that. I was just gonna laser cut a star or 3D print one, and then run some LEDs around the edge. I thought that'd be fun. But you have to have a Christmas tree topper. It's kind of important. Come on. So if this doesn't work, I actually have this other stuff called solder wick, which might actually end up being more helpful. Solder wick is like a copper braid that, remember I was talking about capillary action earlier? It uses that sort of physics to get molten solder to climb up onto it. So I'm just trying to move this. It ain't budging. Alright, we'll grab some of that solder wick. Here we are. So this is what I'm talking about. So essentially it's just like a braid of copper in this wheel. And what I do is, because everyone's got their opinion on how to properly use it, I just kind of smoosh it out. Oops. Pull it apart, so you kind of like make it thicker. And then what you do is you just kind of put it on the pins, and then you heat like so. And then you heat up the pins on the other side of the copper wick with the soldering iron. But you gotta be careful because the solder wick does get super duper hot. Because it's still all metal, right? And so like you can see that it kind of like sucks up some spots of solder. Some people find this like incredibly relaxing. I think I'd be a lot more relaxed by it if I wasn't on stream. So you want to kind of try it from like just different angles and they're just like a couple of problem pins. So solder wick, I guess, is really good for like a trouble area, while solder sucker is really good for like a trouble point. I'm just like holding this into it until I see that it melts. So I kind of want that confirmation that it's even working. Everyone's got different techniques. So this side's almost done, except for this like kind of last one. I'm actually gonna crank up the heat on my soldering iron because I'm getting annoyed. Throw some more flux on it. That's like actually too much flux. I thought that's not a thing. I think it might be a thing. And I'm just kind of also like pushing each pin because like if you can move it around you can tell that it's free, right? So like these ones move. This one does not. These ones do. That one moves. But you see, like, you're just kind of trying your best. So if I can at least get this one. Ooh, I see it gets shiny. Maybe I'll try some of this solder wick. But I mean, this is some of the frustration, you know what? And this is just part of the process. I'm not like upset right now or anything, because like this is what we do every day. If you get upset about these little stuff, you're never gonna be okay when you do the big things. You're never gonna get philosophical, huh? So I'm just seeing if these are, because I want to at least get one side free. I want to know if that's even practical. Because I don't really want to have to cut it out. That would suck. I don't want to waste a whole matrix. But if worse comes to worse, I can cut this one out and solder in a new one. Are you guys planning on making stuff for Christmas? I know I have been secretly planning for several months now all the different stuff, and I know this person who's gonna get this doesn't watch Twitch, but I am making someone in my family a laser cut topography map. I'm very excited. It's gonna be of a waterway that we all grew up sailing on, and so I think this person will like it very much. And I'm really excited to see if it looks good because, ooh, that one's free. Because it'd be cool to see if this could work for like a Dungeons and Dragons maps or something like that. Dungeons and Dragons stuff's already so expensive. It'd be nice if you start making your own. I certainly don't mean like writing a campaign though, that's hard. So you guys can sort of see where we're at now with this. Oh, that's the wrong side. Oops. So these ones. You see how like they're much cleaner than the other ones, but they're still not quite coming loose, which is annoying. Which I think means it's just a few of them. Like this whole bottom row is all set. I think I just need to be a little more patient. Oops, shoot. Drop solder wick. Maybe I just like need a new angle. I certainly need to try something, because this ain't working, dogs. There we go. I think we're getting closer. This is not great for your back. Gonna be honest. Okay, let me try a little bit more muscle. Oh, oof. Okay. Okay. There's some like loud sounds happening, guys, when I shuffle this. So I'm hoping that's a good sign. Oh! It's just a lot of... It's very intense. No one tells you that. Electronics are hardcore. Haha! Okay, this side's coming out. Oh, we're so close. Ow. Oh. Oh, I'm bending. Oh, I'm bending my needle nose. Ah! Ah. Okay. So this side's coming out, but this side is not. Getting closer though. I think I'm just going to I'm so close, but I'm already bending it, and like I'm afraid I've already broken some of it. So I think I'm going to have to... I'm just gonna cut it. It's like... We can order more. So I'm just cutting off these legs. They're flying everywhere. And now that I've done this, I can just, honestly, probably just lay this wick across it like that. I mean, if I could get at the underside some more, I would just, oof. I don't know if you guys hear, like, they just fly off in every which direction. Okay. Oof. Ooh. Okay. Got one side off. Ugh. If I can just even cut the other legs, that'll just make my life easier too. So what I'm doing right now is I'm just trying to like push the pins out of the holes using the soldering iron. Ow. Then you do that and yeah, burn yourself. This is rough waters, I'm gonna be honest. Now it's like, it's a pretty robust printed circuit board, which is good because I am like destroying it. Holy cow. I'm hoping that it'll work still. Gosh, now I'm nervous. Yeah, screw it, I guess. I just have to start breaking the backpack off? Not the backpack, the matrix. Jesus. This can't be the right way. I think I'm just getting destructive in my frustration. Okay. There we go. Okay. That's some progress. Okay. There we go. Aha! I win. Ah. Yeah, so that's a bit rough. And so some of the holes are still filled. And I'm covered in stuff. But I can just heat them up and push this soldering iron tip through. And that should clear them. So I'm actually going to heat it up this way and then pull the remainder of this pin through it. If I can. Helping hands to the rescue. So all I'm trying to do is heat from one side and then suction away the excess from the other. Ooh. Whoops-a-daisy. I just pulled out some of the rivet, but I think it'll be okay. There we go. Yeah, these like rivets keep popping out. Hey, there's a person in the chat. What's up? So, we're trying to make these LED name tags. Yeah, I guess this is a good recap because we got some people going in. We're making LED name tags. Here, let me plug it in. and they flash your name. It's pretty fun, right? And so these are actually for an event at the Smithsonian, not this Friday, but the next Friday. And I am trying to make a second one, but I soldered in this LED matrix upside down. So I'm trying to clean it out so I can put in a new matrix, but it's kind of rough, I'm gonna be honest. And so if you guys like want to be hearing more about, ooh, I cut into some of the trace there. You see how I can see some of the copper on the, if it'll focus. Well, anyways, up here there's some copper exposed, and so I'm afraid that might be making this broken. Nonetheless, we have this functioning one, and so I kind of got sidetracked because I was going to show you guys about how to program it. So let's just go ahead and go through this one, because I can get caught up doing circuit repair all day long. So we've got this one going, right? And it's pre-programmed right now with my name, which is kind of boring.